Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 8, the difference between theoretical probabilities and estimated probabilities. So we're going to compare theory with estimations. So the classwork says, have you ever watched the beginning of a professional football game? After the traditional handshakes, a coin is tossed to determine which team gets to kick off first. The toss of a fair coin is often used to make decisions between two groups. Example 1. Why a coin? Coins were discussed in previous lessons this module. What is special about a coin? In most cases, a coin has two different sides. A head side, heads, and a tails side, tails. The sample space for tossing a coin is the set of outcomes, heads, or tails. If each outcome has an equal chance of occurring when the coin is tossed, then the probability of getting heads is 1/2 or 0.5, 50%. The probability of getting tails is also 0.5. Note that the sum of these probabilities is 1. And if you move the decimal places to the right, boom, 100%. Okay. The probabilities formed using the sample space and what we know about coins are called theoretical probabilities. Using observed relative frequencies is another method to estimate the probability of heads or tails. A relative frequency is a proportion derived from the number of the observed outcomes of an event divided by the total number of outcomes, which we've already done in prior lessons. Recall from earlier lessons, I spoke too soon. Recall from earlier lessons that the relative frequency can be expressed as a fraction, a decimal, or a percent. Is the estimate of a probability from this method close to the theoretical probability? The following example investigates how relative frequencies can be used to estimate probabilities. So it here says Beth tosses a coin 10 times and records her results. Here are the results from the 10 tosses. First toss, heads. Second, heads. Third, tails. 4, heads. Fifth, heads. 6, heads. 7, tails. 8, tails. 9, tails. And the last time she tossed it, a head was the result. The total number of heads divided by the total number of tosses is the relative frequency of heads. It is the proportion of the time that heads occurred on these tosses. The total number of tails divided by the total number of tosses is the relative frequency of tails. As you can see here, there were 6 heads, 4 tails. Alright, so A. Beth started to complete the following table as a way to investigate the relative frequencies. For each outcome, the total number of tosses increased. The total number of heads or tails observed so far depends on the outcome of the current toss. Complete this table for the 10 tosses recorded in the previous table. So we have HHT. Let's finish filling this out so we don't have to keep going back and forth and back and forth and back and forth. We have to see what happened 4, 5, 6, and all the way up to 10. So it was HHT. Then 3 heads, 3 tails, and then a heads. So it was 3 heads, 3 tails, and then followed up by 8 heads. Okay. Now it says the total number of heads so far. 1, 2, and we're just going to tally heads. So here's the third one. 3 heads, 4 heads, 5, and then down here 6. The total number of heads so far did not change, so it went 1, 2, 2, 3, 4, 5. That still was a total of 5, so that doesn't change until heads occurs. So it goes 1, 2, 2, 3, 4, 5, 5, 5, 5, 6. Relative frequency of heads so far to the nearest 100. 1 out of 1 is 1. 2 out of 2 is 1. 2 out of 3 is 0.67. 3 out of 4 is 0.75. Okay. 4 out of 5 equals 0.80 or 80%. 5 out of 6, 5 out of 7, 5 out of 8, 5 out of 9, then finally 6 out of 10, which is 0.60. Now if I calculate these, let me get my calculator. Okay, so now I just need to calculate the outcome 5, 6 as a decimal. So it's 5 divided by 6, enter, and I'm just going to write 0.83 repeating. So that's 0.83 repeating. And then I go and I do 5 divided by 7, and it's 0.7143, approximately 0.7143. I'll just do 4 decimal places. And then 7 divided by 8 is 0.875. Okay, and then 5 ninths, 5 divide 9, enter, is a little more than a half, 0.556, and that's round. So that should be approximation right there, and up here as well. And up here as well. Anyhow, next step is to do the total number of tails so far. So heads came out, so that's 0. Heads 0. There's our first tails, but then heads, so it stays 1. Head stays 1. Head stays 1. Tails goes to 2. Tails goes to 3. Tails goes to 4. Head stays 4. And then we do the fraction 1 over 4. 1 out of 4 equals 0.25. 1 out of 5 equals 0.20. 1 out of 6 equals 1 out of 6 equals 0.16 repeating. Okay, and I'm going to be picky about that. Approximately 0.1667. 2 out of 7 is approximately 0.2857. And 3 out of 5 is approximately, not approximately, that's exact. 3 out of 5 is 60%. Where'd my 2 sevens go? 0.2857. 4 out of 9. Oh, using the wrong denominator here. 2 out of 7, this should be 3 out of 8. So it's not 0.6. Let me fix that. 3/8. I looked over here instead of here. 3 out of 8. That's exact. 3 divided by 8 is 0.375. So that's equals, not approximately. And 4 out of 9 should be an approximation. 4 divide 9, enter, 0.4 repeat. And finally 4 out of 10 equals 0.40, 40%. Okay. So there's our table for them. B says, what is the sum of the relative frequency of heads and the relative frequency of tails for each row of the table? So what they're saying is, what is 0.75 plus 0.25? 1. 0.8 plus 0.2? 1. 0.83 plus 1.1667? 1. So they all, if you keep going, they all add up to 1. Probability of heads plus the probability of tails equals 100%. So those are the only 2 outcomes. So the sum of each row is 1, or 100%. Okay, part C. Beth's results can also be displayed using a graph. Using the value of the relative frequency of heads so far from the table in part A to complete the graph below. So started with no flips, so obviously there's nothing going on until we do the first flip, and we got a number of tosses, relative frequency of heads so far, 1, and then we got another one, and then it dropped down to 0.67. And Beth continues tossing the coin, recording the results for a total of 40 tosses. Here's the results of the next 30 tosses. So it says here to use the value of the relative frequency of heads so far from the table in part A to complete the graph. Okay, so we need to complete that. So let me use red dots first. And so 3 was 0.6 something. So if I go back to my table, it was 0.67. then it went to 0.75, then 0.8. So then it went up to 0.75, then to 0.8. Then after 0.8, it went 0.83, then 0.7143. So 6 was 0.83, and then 0.7143 is just over 7, and 0.875, and then 5556. 0.875 and 0.5556, just a tad over a half, and then finally 10 was 0.6. So now if I drew a line to connect those, I won't take the time to draw straight. I'll do the best I can. It's going to go here, here, up a little, then down, then up, then down. So there's our graph. Beth continues tossing the coin and recording the results for a total of 40 tosses. Here are the results of the next 30. So it's these three columns. There's 10, 20, 30. Okay. As the number of tosses increases, the relative frequency of heads changes. Complete the following table for the 40 coin toss. Number of tosses 1, total number of heads so far 1, relative frequency nearest 100 was 1.00. When did we get 5 heads? So if I come up here, number of tosses 5, so if I go up here I look at 5, that was 0.8 from my table, so that is going to be 0.80 because there were 4 heads by the 5th toss. So if I go back here and look, here's the 5th toss right here, and I have 1, 2, 3, 4 heads. Okay? And we're going to continue this. So after 10, I just look at my graph, we were at 0.6. So at 10, we had 6 that were heads. That was 0.60. And then 15, we have to count up to here. We have 2 more heads, so that is 8. I'm just going to finish this column out first, and then we'll do the math after. After 20, that's right here. There's 3 more heads. 1, 2, 3 more heads, so that's 8 plus 3 is 11. And then 25 is here, and there were 2 more. That's 13. And then there's 1 more heads up to 30, so that's 14. And then to here, there's 1, 2, 3 heads. Adding to 14 is 17. And then 40, there were 2 more, which is 19. So there's a total number of heads so far. And the relative frequency now is 8 divided by 15. So now I have to do these calculations. 8 divided by 15 equals 0.5333, 0.53. 11 out of 20 is 0.55, 0.55. Then we do 13 divided by 25. That's 0.52. And then 14 out of 30 is 0.46, 0.47. And then 17 divided by 35 is just less than 50%. And it's 0.4857, 0.49 rounded. And then 19 out of 40 is 0.475. I'm going to round to the 100th, like I said, 0.4. Okay, so there's our table of frequencies. Now look what's going on. We started at 100%. First toss we got a heads, and then after 5 tosses we had 4 heads, so it dropped from 100% to 80% to 60 to 53, back up to 55, down to 52, down to 47, back up to 49, down to 48. So if you notice down here, the more times we toss, the closer we are getting to and staying near 50%. Now E says use the relative frequency of heads so far from the table in part D to complete the graph below for the total number of tosses 1. So at 1 we were at 1. We use the red for the dots. At 1 we were at 1. And at 5 I think we were at 4, which was 0.8. That dot should not be 0.1. The dot should be 100% up here. Then at 5 we were at 0.8. Then at 10 we were at 0.6, if I remember correctly. And then I need to look up 15. So at 10, yes, we're at 0.6. And then at 15, we're at 0.53. So at 15, we're at 0.53, which is just less than half between 5 and 6. And then at 20, we're at 0.52 and then 0.47. I'll do 2 at a time. So 0.52, 0.47. Okay, now we have to check 30 and 35. Did I miss one? I think I did. So we have 1, 5, 10, 15, 20. It's the trouble with these page to page. 1, 5, 10, 15, 20, 100, 80, 60, 53, 55. 100, 80, 60, 53, 55, and 25 was 13, which is 52. Okay, that's where I went wrong. 25 is 0.52, which is up here. Okay, 25 is at 0.52, 30 is 0.47. So 0.47 is about here. 35 and 40, and we're done with going back and forth. 49 and 48. So at 35, we're at 49, and then 48, just a little bit less. Okay, so then when we combine these, or connect these, I mean, here's what our graph is looking like. So it's coming down close to 50%, and then it's staying around 50%. So it says, what do you notice about the change in the relative frequency of the number of heads so far as the number of tosses increases? Okay, the relative frequency decreases, and it's getting closer to the, go back to this, theoretical probability. Okay, in theory, it should be 50-50, and that's what we're getting closer and closer to as we go out. So it says, if you toss a coin 100 times, what do you think the relative frequency of heads would be? Explain your answer. I would say it would be about 0.50. And the reason is, the probability of heads and tails is equal or likely to occur. Based on the graph of the relative frequencies, what would you estimate the probability of getting heads to be? And I'd say it's 1/2. Okay, based on the, because if you look here, it started at 100%, and it decreased, 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 and it kind of hovered there, and dropped actually below 1/2. So our relative frequency is right here. And that's what we're actually getting close to staying. It's 50%. It's 50%. Okay? Alright. I. How close is your estimate in part H to the theoretical probability of 0.5? Okay, part H. Okay, it says based on the graph and the relative frequencies, what would you estimate the probability of getting heads to be? H. Okay, so in part H we had, I said 1/2 or, try this with my pen, or 0.50. And then back here it says how close is your estimate. Part H is the theoretical probability of 0.5, and I would say they are equal. Would the estimate of this probability have been as good as if Beth only tossed a coin a few times instead of 40? And the answer is no. The less that you do it, the further away from the theoretical probability you're going to take. Okay, the value of you gave in part H is an estimate of the theoretical probability. It's called the experimental or estimated probability. So you usually estimate what you think is going to happen. So exercise 1 through 8. Beth received 9 more pennies. She securely taped them together to form a small stack. The top penny of her stack shows heads, and the bottom penny showed tails. If Beth tossed the stack, what outcome could she observe? Okay. The outcome she would observe is she would get heads if it landed the head side up, tails if it landed the tail side up, but now we have a new one, and it could land on its side. So there are 3 possible outcomes now. A penny will not land on its side and just stay there on its edge, but many of them taped together, 9 of them taped, or 10 of them taped together, would definitely be probably more likely to land on its side than it would be on its top or bottom, which would be in the shape of a can or a cylinder. So now it says Beth wanted to determine the probability of getting heads when she tosses the stack. Do you think this probability is the same as the probability of getting heads with just 1 coin? Well, I would say no, because I think it would land on its side more times than on its tails side or heads side. Simply because the side's larger than the face of the coin with 10 pennies, it's more likely to land on its side. So no, it will no longer be 50% of the time landing heads. It'll probably be more than 50% landing on its side, and more like 25% with less landing on tails or heads. So 2 says make a sturdy stack of 10 pennies, in which one end of the stack has a penny showing heads and the other end has tails. Make sure the pennies are taped securely, or you may have a mess when you toss the stack. Toss the stack to observe possible outcomes. What is the sample space for tossing a stack of 10 pennies taped together? Do you think the probability of each outcome on the sample space is equal? Explain. Okay, so there's no way for me to show this on this screen here using this computer because I don't have a camera. If I had a camera, then surely I would do this activity, but at this point, okay. So now it says record the results of 10 tosses. Complete the following table of the relative frequencies of heads for your 10 tosses. Let me see if I can come up with 10 coins, and if I can, maybe I'll just do this, and you can listen to it banging around on my desk, and I'll record it. Okay, so I'm going to conduct this experiment. You'll just have to take my word for it. I didn't have pennies, so I only had quarters in my desk, so this is going to cost me a little more money. If I had 10 pennies, it would only be 10 cents, but I have 10 quarters. That's $2.50. So I'm going to toss this on my desk. You'll hear it, and then I'll tell you what it says. And that was on its side. Relative frequency of heads so far, 0. Flip it, toss it, and it landed on its side, just as I suspected. Side would come out more frequently. Toss it. That time it came out heads. So that happened, that's the first time. On its side, still 1. On its side, still 1. Heads. It's 2. Heads. 3. Heads. 4. side, still 4, and last time on its side. So 4 times out of 10 it landed on heads. Okay, so no tails occurred. Based on the value of the relative frequencies of heads so far, what would you estimate the probability of getting heads to be? Okay, so if it was 4 out of 10, I might say 0.4. 0. Based on my frequency here so far. I had 4 heads out of 10 flips, so I'd say 8.4. Now down here it says to toss the stack of 10 pennies another 20 times, complete the following table. Okay, I will not bore you with this. I will pause the video and I will flip these behind the scenes, then I'll come back with my totals. Okay, so here's my outcome. I didn't get any more heads, 0 heads. The rest were all sides and tails started taking over. So summarize the relative frequency of heads so far by completing the following table. Number of tosses, 1. So if I go up here, my first toss was a side, so that was 0. Number of heads, 0. When I got to 5, 5 is right here. Let me change colors. 5 is here. I had 1 head. Oops. Oops. Down here, not the next page. It's going to be 1. So let me just change color here. 0 and then 1. And then I go back to 10 tosses. And that is right here. I had 4. Okay. And then 15 tosses is right here. I had no more heads ever. So I can just go like this. 4, 4, 4, 4. That's easy. So relative frequency of heads so far to the nearest hundreds, 0.00. 1 out of 5 is 0.20. 4 out of 10 is 0.40. 4 out of 15. 4 out of 15 is 0.26 repeating, 0.27. 4 out of 20 is going to be 2 out of 10 or 0.20. 4 out of 25 is 0.16. 4 out of 30 is 0.13. Okay, so there's my table. So I started out at 0. I got all the way up to 40%, but then it plummeted. I never saw heads again. Based on the relative frequencies for the 30 tosses, what is your estimate of the probability of getting heads? So if I look back at this, I would estimate it at about 13%. Based on my frequency of 30 tosses. Can you compare this estimate to theoretical probability like you did in the first example? Explain your answer. Here I would say no, because there's a greater possibility of it landing on its side. It's no longer 50-50 chance. And since there's 3 outcomes, I don't feel that the side is going to be equally likely to occur with heads and tails, so I would not call it one third. That's all I'm going to say about that. That's just me. Now number 8 says create another stack of pennies. Consider creating a stack using 5 or 15 or 20 and tape them together the same way you tape the pennies from stack 10. Okay, so now I'm going to do this again. I'll add more quarters to my roll. We'll see what happens. Okay, so what I had done was I added 9 more quarters to my roll, so I had 19 quarters. Okay, which was $4.75, I believe. And the first 10 flips, it landed on its side. The first 12. Finally, I got a heads on 13, and then a few more down below, and no tails. So those were my results here. Okay, so I recorded the outcomes, and now I got to, and that's it. Okay, so they didn't ask any questions here. Again, make sure any questions on this. Create a stack of pennies. Consider toss the stack 30 times. Record the outcomes for each toss. But then it doesn't ask any questions. That's odd, because what is going to happen is we saw that heads came up 5 times out of 30. which is 1 out of 6, and if I do that calculation as a decimal, 1 divided by 6 is 0.17. Okay, so the probability of heads back here, we only tossed it 30 times, was 0.13. So heads actually occurred more than I expected because I thought it would decrease with the increased number of quarters, making this roll longer. I thought it would land on its side more frequently, which it kind of did at first, but heads appeared a few times after that, but never a tails. Okay, so anyhow, that is the end of lesson 8 of your problem solving.